Okay, so hello everybody. Welcome to my session about RESTful Hypermedia APIs. Before we start, I'd like to introduce myself. My name is Tödter. I work for Siemens Building Technologies, located in Munich, Germany. I'm a huge fan of web technology and open source. I have an email, so if there's any open questions after the session, I will stay here the whole conference, also tonight, but you can reach me by email or social media like Twitter or Facebook. Before we continue, I'd like to know a little bit about you. So how many of you have implemented a RESTful web service? Oh, this is almost all, what would be 80%. How many of you used Java technology for that? Oh, that's almost everything. How many of you use Spring Boot and the ecosystem? This is about 50%. Who uses Java EE, Jersey, JAX RS? Okay, 30%. Other frameworks like Rails or Play or so? Just a few, okay. How many of you are using Hypermedia already? One? Okay. So the goal for today is that you get an idea and impression what's Hypermedia all about, and that you can decide for yourself if this would be something where your very own products or projects might benefit from. So many of you have already implemented REST. So just a question, how many of you know the basic principles of REST, the architectural constraints? 50%. How many of you could explain all the REST architectural explains to her neighbor or his neighbor? One, okay. Don't worry, I don't want you to come up front, but I will go over it very quickly so that we are on the same level. Then I will talk a little bit about this abbreviation no one, including myself, can pronounce correctly. So it is for hypertext as the engine of application state. Some say HATEOAS, some say HATEOAS or HATEOAS or something like that. I will just refer to it as the hypermedia constraint. Then I will give some concrete examples, mostly in Java, but I also have some JavaScript examples. And for me, when it comes to APIs, the documentation is a very important topic. So I will discuss a little bit what's already there, and we'll show you some examples for good hypermedia documentation tools. And of course, I hope we have time for some demos and live coding. Okay, let's go quickly over the REST basics. So what is REST? Most of you might know. REST is for representational state transfer. It was created by Roy Fielding in the year 2000 in his dissertation. Just a quick check. How many of you have actually read Roy's dissertation, or the chapter 5, which is about REST? Okay. I can really recommend it. It's pretty small, so you can read it, I don't know, 1 hour or so, and it's a very precise and concise explanation about the architecture principle. If you Google for Roy Fielding REST dissertation, you find it immediately on Google. It's publicly available. So it's a software architecture style. And what I want to point out here, even though it is pretty clear what is REST and what's not, if you read Roy's dissertation, many people say or think that REST is just using CRUD, so create, read, update, delete, using HTTP protocol. And yes, this is a part of REST, but this is not the same. So REST is much more than that, and hopefully I can get into a few more details about this later. So let's begin. So here are the architectural constraints of REST. First is client-server. It seems to be very obvious. So we have a client that makes calls to REST server. But when many people see client-server, what they think is UI and backend. And yes, this is one important use case, that you have a user interface like a web UI, and this web UI makes calls back to your RESTful backend. But of course, each RESTful service itself can also be a client making REST calls to other RESTful web services, and so on and so on. Stateless is one of the most important things in my point of view. That means that all information that a RESTful web service needs to operate is given at a call. So what parts of information do we need? First, we have the URL where we make the call that might contain parameters. Then we have so-called request headers. For instance, if we use security, we probably want to specify an authorization header with a value bearer and then a token for OAuth2, for instance. And we have probably a body if we do a post to create some object. But that's basically it. There's nothing that the service itself stores internally, like a state or so. So everything it needs, is given in the input, then it processes the request and gives back some output in form of a body and also response headers. If we go stateless, we have lots of advantages. One is that we can just shut one service down and start it up, and it should work out of the box because no state have to be saved or so. We can scale. If we have lots of requests or so, we could just fire up a few more services and then putting a load balancer before them and redirect the calls to the services that don't have load, and so on and so on. We could use caching, we could use several techniques and so on. And this is all possible because of the stateless notion of the server. Cacheable, very important. So when we do network calls, we want to optimize them for performance. So we know that usually a network call can be 1,000 times or 10,000 times slower than a local call. So what we want to do, we want to either avoid them if we can, or we want to make the payload as small as possible. And the caching system that is given by HTTP, we can use directly when we use RESTful web services. For instance, there's this header cache control, and the service could say, well, you know, the data I give you is valid 120 seconds. And then I, as a client of the service, know if I want to make a call in 10 seconds, I can avoid this call because my data is already valid and will be valid the next 110 seconds then. Another nice thing is e-tags for entity tags. So if a server provides me with an e-tag and with the payload, at the very next request I can say, dear server, I want to make this request again, and by the way, last time you gave me this e-tag, which is kind of a hash code or a unique ID. And then the server internally can check if the content would have changed compared to what I already have. And if the server decides no, it would return exactly the same content than it returned 10 seconds before, it would just return as 304, which is not modified. Of course, this is still a network call, but it's much faster compared, for instance, if I get back, say, one megabyte of data, and then I don't know if this is fresh, I have to reparse it again. If I done that, I make the call again, and the server says not changed. I have to do basically nothing and can use my very own cache infrastructure. Layered system, I already mentioned. So if I'm a client and I'm calling a RESTful web service, even though I might think that the REST service is exactly behind the URL that I invoke, in reality, it could be a layered system. So usually, for instance, when we go to Amazon, for instance, or to Google or to eBay, we have an API gateway or a front page server or front server that then redirects our calls to the several load balancers, to several caching layers, and so on and so on. And in the end, we will end up at the real service that processes our call and then gives back the result over the chain to the client. But through the layered system, we can architect a system that is then really optimized for some non-functional requirements like scalability or redundancy or availability or what have you. Code on demand is optional in the specification that Roy Fielding wrote. The idea was that a service could also return some JavaScript or other executable code that could then be executed at the client side. And mostly for security reasons, that is not very popular. So I don't know any service who's actually doing that, or very few. For a uniform interface, I have a whole slide. So within REST, we identify so-called resources. And the resources are basically related to the internal model of the service. But we never know the internal model of the service. What we know is the representation that we can deal with. For instance, I can say, well, you know, I only deal with JSON data. Please, I would only accept application/JSON. And then if the service can produce JSON data, it would give me back a JSON, and then I would use this JSON for further manipulation of the data. For instance, when I get something, then I change an attribute, then I use put or patch to change the resource on the other side. Within REST, it is best practice that we use the verbs given by the HTTP protocol to express what we want to do. So if we want to create a new REST resource, we usually use HTTP post. If we want to get something, we use HTTP get. We want to update, we use put. If we want to update the whole thing, we use patch. If we want to update only one thing. And this is just best practices. There's many systems out that don't use patch at all, that only use put, or many use just post for all of this. But this is one of the recommendations. If you can, try figure out if there's some value for you. And of course, delete for delete. The messages selber are self-descriptive. So this is together with stateless. So everything a service needs to be executed is given by the messages containing the HTTP verb, the URL, and the parameters, and the request headers in the body, of course. And the last thing, and the main topic for this talk today, is Hypermedia as the engine of application state. For that, I would like to present you the maturity model that Leonard Richardson, he's a colleague of Martin Fowler working at ThoughtWorks, once created, and Martin Fowler was so nice to wrote this up. I put the links in the slide. Here, if you Google for Richardson maturity model, you will find this as a very first hit at Google. And it's nicely written. I think you can read it in 20 minutes or so. So Leonard started with the level 0, and he called it the swarm of POCs. POCs is for plain old XML, but it doesn't have to be XML. It can be unstructured data or key value pairs or whatever. Let's imagine we have a hospital, and the hospital wanted to provide a level 0 API. How would this look like? This would look like that the hospital provides you with a single API entry point, www.myhospital.com or whatever. And then you have to know some contracts. You have to know, well, if you want to get a list of the doctors, you have to provide some XML or data that you send to this endpoint. And as a result, you would get some other data, probably also XML, that gives you a list of the doctors. And so you would have to know what different kind of data you have to would send to the endpoint, what kind of data you would get back, and then you could pass them. It is basically that HTTP is only used as a transport protocol to transport data from the client to the server and back. In level 1, the next level, we have resources, meaning we wouldn't have just one single entry point for the hospital. We would have, for instance, an entry point for all the doctors. So if I would get a list from the doctors, I would say my hospital/doctors, and then I would get a list of the doctors. And for instance, when the first doctor is called Dr. Mueller or Roberts, I could say probably my hospital/doctors/Dr. Roberts, and then I would get the details. But if I want to get a list of, or if I want to make an appointment with this doctor, I would use the very same resource URL and code whatever I want to do as new verbs in URL parameters. For instance, I could say, well, my hospital/doctors/Dr. Roberts, question mark, make appointment equals some data encryption or so. In level 2, we wouldn't code any verbs, what we want to do, into resources as parameters. What we would do instead we would create or use new resources as nouns. Resources in the REST area are always nouns, or should be always nouns. So let's take another example. So imagine you want to write a REST API for a printer. And in your domain model, you have a printer class that has a method print. So in your domain model, if you want to print, you would get an object of this printer and then invoke print with some parameter. You could easily map this to level 1, saying we have a printer resource, and then we say my company/printer/printer1 question mark print, and then having there some parameters to give the printer information what to print. In level 2, you wouldn't do that because we only want to use HTTP verbs. So instead of coding the verb print into the URL, we would create a new REST resource, for instance, a print job. This is exactly how Unix and Linux is doing that. So to print, the workflow here would be to do a post request on the print jobs REST resource and give it a printer as a parameter or something in the body, a JSON in the body which says, well, this printer, this file, and this other printer parameters. And then the job would run, and we could make requests, for instance, saying, well, dear system, give me all the running print jobs, for instance. And when the print job is done, the REST resource would delete itself, and that's basically it. And the level 3 then would be that those REST resources are linked to each other. For instance, if I have a printer already as a REST resource, I could see, well, does this printer resource provide me with the links to its print jobs? And for instance, my client could be as smart as saying, well, I get the printer resource, the REST resource, and check if there's no link to print jobs, I know this printer is idle, isn't printing anyway. If there's print jobs, I would get the print jobs exactly for this printer. And I could say, well, dear printer, give me the links to your print jobs. I follow the links and would get all the print jobs of this particular printer, right? And back to the hospital, for instance, if I say, well, give me the REST resource for a certain doctor, Dr. Roberts, and I get this, then in the result, I could get links that say, well, appointment job or make appointment job or whatever that leads to REST resource to create a new appointment with Dr. Mueller or Roberts. Once I have this appointment as a REST resource, the appointment REST resource could provide a link saying cancellation. And if I want to cancel this resource, I don't have to know much about the internals. I just have to know that I have to look for a link with the name or ID cancellation, then I follow this link and I know my appointment is cancelled. And I want to mention this halo here. This is also in the original picture that Leonard wrote. This is a little bit, please don't try to be dogmatic about this. So when someone comes up with a maturity level of any technology, then all of a sudden people come and say, well, you know, Kai, I had a look at your REST API and I can tell you it's not REST at all, because it's only level 1 or level 2, and Roy said if there's no hypermedia then it's not REST, so you don't have hypermedia, so please don't call it REST API. It's not, right? And my answer to this is a maturity level in terms of the pure specification of REST. It doesn't mean that the API is good or bad, right? So if you have an API, say on level 2, and you are fine with it, and your customers are fine with this, and it's working very good, then there's probably no reason to lift it on level 3 just because you can. Right? So there's always costs with it. But on the other hand, when you have nothing, starting on a green field, trying to create a new API, then it's often very easy and doesn't cost anything, a little bit related to the technology stack that you use, to start with a level 3 API in the first place. For instance, when you're using Spring Boot together with Spring Data REST, and I have examples later, you will get all the hypermedia stuff for free. You don't have to do anything, it's just there. Okay, so a little bit, so for me, hypermedia APIs for services are a bit like web pages with links for humans. For instance, almost every day I have a list of bookmarks that I check. For instance, in Germany, very famous Heise news ticker. I click on there and I get an aggregation, I get a list of links, right? With headlines. I just read the headlines, then I decide if it's interesting for me or not. If it's interesting, I click on the headline. But only the headline is I'm interested in. If this link points to a server in Munich or in London or in China, I don't care about. I only compare, this is the headline. I know if I follow this link, I will get the content I'm interested in. And also, if Heise news ticker has a branch in Hamburg and one in Munich, and today this links to the server in Munich, and tomorrow it links to the server in Hamburg, I don't care. This is nothing of interest. And I will come to this later, how important are actually the actual endpoint URLs when you design an API. Okay, a little bit about existing hypermedia representations. So there's a lot of hypermedia representations out there. On the one hand, this is good because we have the choice, so we can gather our requirements and then pick the one we want to use that comes closest to what we want to do. On the other hand, often it is nice to say, well, if you, I don't know much about this, it would be great if there would be a standard or de facto standard. I would just use it like everybody else, and I could talk to people and would be a bit more compatible with others. So unfortunately, there is no de facto standard here, but the first one, HAL, and I have slides for the first two later, is one of the most popular. Probably because it's one of the most easiest to use. Of course, there's a lot of functionality that cannot be done by HAL, but by others. But on the other hand, for many use cases, it's enough. That's one reason why we at Siemens Building Technologies we are very, very fine with using HAL. So HAL is for hypertext application language. By the way, how many of you have seen the movie 2001: Space Odyssey? Very old movie. I think 1968 or so, the first movie. There was an evil computer called HAL, and the myth is that the name was chosen because this is the letters IBM shifted one letter or so. But this is just a myth, and this HAL has nothing to do with it. It's for hypertext application language. It's by Mike Kelly, and we have representations both for JSON and XML. And as I said before, it's very popular, I think mostly because it's so easy to use. So how does a HAL JSON document look like? And I'm referring in this talk only to the JSON representation, not to the XML, but it's from the semantics, it's basically the same. So what I like about HAL is that if I have an existing JSON that has top-level keys and values that stay exactly the same and are not touched by the internal structure, then additionally I have links that could link to other REST resources, and I also could embed resources. And those embedded resources could contain the same plain old JSON properties, links to other resources, other embedded resources. You see this is a recursive structure, but in reality, we usually see 2 or 3, or in a few cases 4, but not more than 4 levels. So I usually use 2 levels or 1 level to trying to make the payload as small as possible. So here's a concrete example how such a JSON HAL output looks like. So here we have the normal properties ID with the value 1 and text with the value hello all. And here in yellow we have the 2 things that HAL provides additionally, which is underscore links and underscore embedded. The underscore is because HAL doesn't want to conflict with normal properties, and it depends on your domain. So if you, for instance, implement a web shop, it's very likely that link is one of your domain attributes that you want to use top level. Or if you build an embedded system, probably embedded would be something you want to use top level in a JSON. That's why here the underscore is used, and of course as a recommendation, never use underscore in your very own attributes. Just use simple identifiers. So one very prominent link that is almost there in all HAL-based REST resources is a self link, actually. And this is the full, so the name is self, it contains an href with a URL, and this is actually the ID of this REST resource. Of course, here in the example, it's just localhost, but if this would be from a cloud-based service, actually I could send you this via email. You could click on this link and would end up in exactly this resource. So the best practice here is if we have a self link here, which identifies the resource, including the protocol, the host, the port, and the path to the resource, we actually don't need this ID here. So for instance, in Spring Boot or Spring Data REST, the best practice is when you use HAL, the ID field will be hidden automatically. And if you want to get the ID of the resource, you usually use the self link here. Another thing is the embedded. Often when you have specific use cases, for instance, you have an UI, the UI wants to display a table, and in one table row you want to have additional information that is not in the resources where you make the request against. For instance, this is a message resource. If you want to do a table with messages, but you want to also display the author of the message within the same table, we want to prevent you from making so many additional calls. So it would be a good idea then that you return something where the important thing, which is the ID of the author in this case, is just embedded. And this doesn't mean that when you make a call to a user resource, which is an author here, that there could be 20 parameters. It doesn't mean when you embed something that you have to copy each and every attribute. Usually we only put the things in here that are required for this use case. Okay, another popular representation is Siren by Kevin Swiber. It's very similar to HAL, and it provides more mechanisms. And of course, everything comes with a cost. So since it provides more semantics, it's also a little bit more complex. But the idea is very similar. So the same JSON data enhanced with the Siren syntax would look like this. First is every Siren response has a class, which is kind of a type or so. So you could parse this and then know immediately that this is a message, right? So when you parse this response, you had to go through the self-link and then interpret this here, and then you would probably know that this is one single instance derived from the messages collection resource. So you could guess this is a message, but this could be anything. In Siren, back again, it is mandatory that each Siren response has a class. Then one thing that is different compared with HAL is that the plain or JSON properties that if you don't use Siren would be on top level are not on top level anymore. They are here within the properties attribute, and here a new JSON object starts. While I find this from the structural point of view, I find this a good structure. From the practical point of view, this will break every client immediately, because the client would expect a JSON where before you Sirenify a client, it would expect that ID and text would be top level, and so you have to change all of the existing clients if you introduce JSON, Siren, and you don't start with it in the first place. Okay, the entities are very similar to the embedded objects, so we can embed other Siren objects that of course have a class and properties and so on and so on. And we also have links. So here in this page, this is very similar to what we have when we're using HAL. Additionally, what we can also specify in Siren is this actions, saying, well, you get a REST resource, and you don't only get the resource. Siren also tells you, well, what you can do with the resource. And you could actually take some of these values and build up a user interface for it. Here, for instance, it says, well, if you want to add an item, if you display it in the user interface, use the string add item. When you do this, use the HTTP method post. Here's the URL you want to post against. Here's the type you want to give it in your request. And then if you want to build a UI to customize this request, those are the fields that you want to use. So along with this information, you could build a generic UI builder that parses the response and builds a UI, which of course doesn't look good, probably doesn't have a good user experience, but at least it would be usable. And then if you give this to a designer or so, it would be much easier for the designer to have an idea how a good user experience could be and how a UI could look like. Okay. So there's a lot of Java implementations. There's low-level implementations where you can build your own structures with builder patterns, and there's some high-level implementations. So low-level implementations are HAL Builder, Spring, HATEOAS, or however you pronounce it, Hilarious, HyperExpress, and so on. And for Siren there's a few. These lists are not complete, but I assure you there are many more HAL-related implementations than Siren. Then there's a few collection plus JSON, a few Hyper, a few Uber, and so on and so on. But for HAL, there's the most stuff. So let's start with Siren, low-level Siren. So if you're a Java programmer and use the library Siren4j, you would get a builder pattern. So you could create a new link builder instance and then say, well, set relationships, set hrefs, and so on. Build this. And when you want to build a result that you return from your RESTful web service, you could also build the response, for instance, here. Adding a property adds a JSON property that's then under the Siren properties structure, and add a link, adds a link, and so on. It's pretty straightforward, but very, very low level. So if you have an existing API and then want to enhance it via Siren, you have to do a lot of work to go through all your implementations and add the links and the structures. Here it's a little bit easier. So you could also enhance your Java resource class from the base resource class of Siren, and then just use the add Siren4j entity annotation, giving some parameters like name and URI, and that's basically it. So HAL Builder is another example for a low-level API. HAL Builder has also Siren support, but I think it's in beta for a couple of years now. I'm not sure if this is used productive, but once you have a infrastructure library that can create the one representation, in this case HAL, it's of course pretty easy to create other representations like Siren that are similar. So here in HAL Builder you say, well, you use a representation factory, create a new representation, and then you can enhance this. For instance, in HAL there is namespaces, so-called queries, where you can also specify for this REST resource here, you find the documentation there. And I will show you this live later in a little demo. Or here adding links, right? But also HAL Builder is a very low-level API, and you have to put a lot of manual work to enhance all your existing code. So the JSON result would look like this. Here's this queries that I was talking about, meaning, for instance, so I have a namespace here that is chatty. So the next link here within chatty wouldn't be just users, but chatty:users. And then I know if I have the namespace chatty, I would find the documentation for this link relationship chatty users under the URL http://docu-chatty.com/users. And I will show you this live in a minute. This is a very nice way of documenting REST APIs and having the documentation very, very close to the actual service itself. Okay, so a little bit about Spring. We use Spring a lot, but myself and many of my co-developers are pretty lazy. So when we create REST resources that we want to implement in Java and then serialize to JSON, we basically use the identifier, but we don't write getter and setter methods. We don't write equals hashcode to string and so on. For that, we use Project Lombok. So if you Google for that, you find it, and Lombok provides us with some annotations. For instance, add data, add scatter setters equals hashcode to string and can equal. Of course, there's a getters annotation that only adds getters. There's a no args constructor, an all args constructor, and required args instructor, and so on. And so it's very easy to just focus on the attributes rather than dealing. So if I add a new attribute here, I would have to change equals and hashcode into string. And so if I use this, I don't have to. Of course, so the critique is, well, I don't know what Lombok is generating here, and probably only I know what could be the best optimized implementation of equals and hashcode. For instance, if I know that the ID in all cases is unique, I could just use the ID as hashcode and not the other parameters. And this is something that only I know. But this is true for corner cases, but in many cases in the real life, I think this is totally okay, doing that this way. So if we have in this case a user using Spring Data REST, we need a kind of container or repository where we can create users, get a list of users, delete users, and so on. And Spring Data REST or Spring Data provides us with the repository interface. There's a CRUD repository, a paging and sorting repository, and others. And we just need to pass the class that we want to put in this case user, and the ID of the type of the ID that the user has. So here in our case, here you see the ID field is a string. I very often use longs as an ID for my REST resources. Okay, so this is the user repository has nothing to do with REST. If I want to expose it in the REST world, that actually this repository is an endpoint. Here in this case, the path would be users. I could use this repository REST resource, and that would be it. And since a couple of years, it is even easier. I don't have to do anything. The system scans, do I have a dependency to Spring Data REST? If yes, every Spring Data repository automatically is exposed as REST repository. And I say, yeah, I have now 10 Spring Data repositories, but 3 of them are private and I only want to expose 7 of them. Then I just go there and say, well, this one shouldn't be exposed, and I make it explicit here. Okay. So, and the good thing is, if we use the Spring Stack, including Spring Data and Spring REST, we get the whole hypermedia, including HAL, and there's also other representations for free, right? The question, it was a nice question at Stack Overflow. One developer asked, they say, well, I would like to use Spring Data REST, but I don't want to use hypermedia. And the answer from Oliver Gierke, the team lead of Spring Data and Spring Data REST, was, if you don't want to use hypermedia, please don't use Spring Data REST. So there's hypermedia built in. This is a very core concept of this all. Okay, so here's a lot of JavaScript implementations. I'm running a little bit out of time. So to sum it up, in my experience, hypermedia helps to build clients that are more robust in terms of URL change, right? So if you write a Twitter client today, and then you browse to the Twitter API documentation, get the 25 different endpoints, copy and paste them in your client, hard-coded. Tomorrow Twitter changes one of the endpoints, your client breaks, right? If you go to the GitHub API, GitHub doesn't use HAL, but uses hypermedia. In GitHub, every link just ends with _URL. If you go to the GitHub API, you only must know that the link to the GitHub users might be GitHub users _URL, and this wouldn't change. And then you write a client that looks for this key, how the link looks like, and you can follow it, and you're good. Meaning, the only URL you need to write a client for a hypermedia API is actually the entry point of the API. And then you would get a list where that you can follow, where you can get the rest of it. This is one nice thing, and the other thing is that hypermedia can provide you with links dynamically at runtime. Meaning, for instance, if you write a shopping cart system and you write an UI for it, so in the workflows, instead of letting the UI compute, when should I enable the payment button? So the UI would have to know all of the preconditions and then say, well, now I know, now I can enable the payment button, and when the user presses on it, it will be redirected to the payment. When the backend uses hypermedia, the contract could be that whenever the UI makes a call, whenever the backend knows that now in the process everything is there that I need for payment, the backend could just provide a link payment which leads to the next step of the workflow, and then the UI could be very stupid, could just do something and then checking, do I get something back with the payment link? No, I leave everything disabled. Do I get something back with the payment link? Oh yes, then I enable my payment button and put the link behind the button, and when I click on it, I follow the link and end up in the next step of the workflow. So in our point of view, clients are more robust, and we are, I mean the teams that I work with at Siemens are big fans of hypermedia. So a little bit, so do I have 5 minutes? I think I have 5 minutes. I have to rush a little bit. A little bit about documentation tools. Probably, how many of you know Swagger? Oh, 60%, okay. Or Open API, it's now called the specification. It looks nice, but it's not very good for documenting hypermedia API. Why? So the adoption is very high, the tooling is very good, but it's UI-centric. So you will get, if you create a UI with 25 endpoints, you will probably get here a list of 100 things, post, put, get for the endpoints. If someone then has to implement a client. He would take a look at this and, okay, here, the pads is the endpoint, pad/find by status, copy that in, and tomorrow if the API changes, the client would break, right? And in the new Open API v3, there's something like links, but it's only a starting point. Right now it's not usable for Hypermedia. So it's not, I wouldn't recommend using Swagger for documenting REST APIs with Hypermedia. What I would recommend would be Spring REST docs. So basically what you do is, how would you make sure that the API documentation is always in sync with the actual implementation? As a Java developer, no-brainer, you would write a test that tests this, right? And the idea of Spring REST doc is to write test against the outcome of the real call, and then make the documentation in the same step. It looks like this. So here we are using Spring Mob MVC. I don't want to go into details. So we do a get to this URL endpoint, do some tests, we check if it's okay, and then we do document and we create something, and we say we would expect that in this call there's a response field called version, and if so, the documentation would be the version of this build, which is of course trivial, but you would write meaningful text here, and so on and so on. So if, for instance, if the implementer of the service would change this timestamp with capital S to timestamp with small s, this test would break. And then you would know there's something not in sync anymore. You either have to change the documentation or you have to change back the service. So if you have embedded this in a build pipeline, it would crash immediately if the implementation and the documentation would go out of sync, right? And I show you some URLs. Let me just show this live. I have a little application running in the Heroku cloud. It's called shady42.herokuapp.com, and there I always generate the API documentation and generate both HTML and PDF. And here's the live thing, how it looks like. So we have a structured HTML. The basis is ASCII-doc, and from ASCII-doc output we can generate everything we want, also Word documents or DocBook or PDF HTML. And the good thing here is, so we could put some manual stuff in it, for instance an overview about REST, what the verbs are, how errors are handled, but here, for instance here, this index, this was a real call in the test. And this was a real result, including the HTTP return code, the content type, the content length, and so on and so on. And the nice thing is, you could provide this together with the application. So here's, I can show you, oh, the service went down. Give it a few seconds. This is a free version of a Heroku web dyno, and it shuts down if it's not used for 10 minutes. And since I was talking much too long, it shut it down, but give it a few seconds, then I will go back to it. Okay, so here's the, you will get the slides including all the links. And of course there's some controversial discussion. So there's pros and cons using Hypermedia, and there's a group of people who think, for instance, oh, this Hypermedia stuff, it bloats my JSON. I want to have concise, small JSON, or nobody really understands how to use it, and so on. And those discussions are very entertaining. But to sum it up again, I think that RESTful Web Service and Hypermedia fit very well together. And this leads to whenever we create the implementation of a new RESTful web service, we use Hypermedia from the very beginning. And let me just okay, now it's there. So if we use HAL, there's an open source tool called HAL Browser, which is also included in Spring Data REST, so it's an extra dependency. But if you do that, we could just now browse the API. For instance, here we see we have chatty users. I can do a GET request, follow this one, and now I would get the users here. I can expand it. And regarding the documentation, since I have specified this query with the documentation for all the links, here in the HAL browser I could just click on the doc, and then I have embedded the generated ASCII docs from my Spring REST docs test here. And this is something when we create services, we usually have a sandbox version of the service where we create test data and we deploy this with us, and then each developer that want to use the service can just browse the data and trying out how the service works. Okay. So that's all I have for now. I'm sorry that I'm 2 minutes over the time. I hope that you got lots of information what's Hypermedia all about, and that you think about it, and probably you want to try it out for a next project. We don't have time for questions yet, but I will stay here. So if you have some time left or so, just come here, and I will also be here the whole night and also tomorrow. Thank you very much.